The resources are shared across the network, and workload in a P2P network is spread amongst all the machines. There is no one central server that's got to do all the work. There is also not one central server that can be hacked or taken down. P2P networks are easy to scale upwards. You just keep adding new users who will then get involved in sharing the workload. The larger the network gets, the faster it gets, as the same workload is distributed across more and more processing devices. Sharing large files is a doddle in P2P because it splits nicely over 1 million machines, and all of those machines will contribute towards the sharing. For this reason, P2P networks are actually quite hard to shut down. They are hard to take out legal action against, since no one actually takes responsibility for sharing the complete file. Now, in the past, of course, this has been the legal quagmire in which we operated because of the illegal file sharing sites. But when you start to add legitimacy to the P2P network and do it properly, it can be really powerful. So, with the legal activities such as copyright infringed file sharing or transactions on the dark web, they're actually all bad ideas. But when you start to legitimize a large-scale legitimate P2P application over a large network, well, suddenly that can become really, really powerful. Let me explain. Famously, the University of California, Berkeley came up with a plan for the Seti project to utilize the unused CPU power of people's home PCs. Whenever they went off to make a cup of tea, or if you put your computer on standby. So in effect, whenever a screensaver came on, or whenever the PC went into standby, in this way, the search for intelligent life, which requires the scanning of the universe for radio signals, was helped along with the immense processing power needed by the world's P2P users. So Seti set up all the world's PCs that once they went on standby, they would offer a trickle of their processing power to the Seti project, and in essence, this project of Seti looking for extraterrestrial life became a project utilizing the world's standby PCs. That is a P2P application. Similarly, another project called Einstein Home was a project that did the same in search for gravitational waves by pulsars. So in this module, you've grasped two really important concepts: centralized networks and decentralized networks. One controls the people. The other is for the people, of the people. So what has this got to do with blockchain? Surely a bunch of amateurs sharing bootlegged copies of the latest Marvel movie over a decentralized network isn't a strong or reliable enough foundation to challenge the entire global banking system. No. This revolutionary blockchain network would have to have a level of security and robustness built into it that is at least as equal to the current centralized systems. And for that, we would need to take a look at the group of people who were spurred on to fire up a revolution. For what we need to look into is the idea of cryptography, a way of securing systems. So how do you secure a P2P system and make it at least as reliable, robust, and secure as the old networks? Well, now we need to get our heads around cryptography, and I'll even introduce you to the cypherpunks.